The overall goal of this procedure is to demonstrate a method to coat metallic shape memory alloy nitinol with graphene for improved hemocompatibility in blood-contacting implant materials. This is accomplished by first growing graphene on copper foils using chemical vapor deposition. The second step is to etch away the copper foils and transfer the as-prepared graphene to nitinol substrates. Next, the graphene-coated nitinol substrates are used for culturing endothelial cells and smooth muscle cells to quantify cytocompatibility. Another assay is to check for hemocompatibility by coating both proteins fibrinogen and albumin onto the graphene-coated nitinol substrates. Ultimately, micro-Raman spectroscopy, confocal microscopy, in vitro cytotoxicity assays, and SDS-page protein analysis are used to show successful graphene coating, improved cell morphology, improved cell viability, and better hemocompatibility.
The main advantage of this technique over existing techniques like polymer coating is that graphene coatings are extremely durable and corrosion resistant.
The implications of this technique extend towards improvement of stent technologies because graphene's inherent material properties are expected to reduce protein adsorption and reduce activation of clotting factors due to protein conformational change.